In this chapter, students will learn about ratios and ratio notation. Ratios and ratio notation are new to sixth graders. However, students have previously learned some skills and concepts that will aid them in their understanding of ratios. Students have learned about multiplicative comparisons in fifth grade when creating equivalent fractions. For example, let's look at 2/3. The numerator and denominator of 2/3 can be multiplied by 2 to generate an equivalent fraction of 4/6. Students have also learned that division is not commutative. 10 divided by 5 is not the same as 5 divided by 10. Let's move on to the new concepts and skills in this chapter. Let's start by discussing what a ratio is. A ratio associates two or more quantities that are related. It is a multiplicative comparison. A ratio is also a comparison by division. Ratios can compare discrete objects, such as people or tables, and naturally, they are in whole number units. For example, this image shows a ratio of 2 yellow cupcakes to 1 chocolate cupcake. Ratios can also be continuous, such as feet in a mile, and can be described in fractions of a unit. For example, there are 2,640 feet per half mile. Ratios can also be constant, such as the number of inches in a foot, or they can vary with time, such as my height in relationship to my age. Ratios can have the same units, such as comparing the number of new cars to used cars on a lot, or they can have different units, such as 30 miles per gallon. Some mathematicians identify a ratio with different units as a rate. However, the standards do not differentiate between comparisons with the same units or different units. Now let's discuss the value of a ratio. Let's use the ratio 4:10. It tells how A and B compared multiplicatively and is often referred to as a comparison by division. The value of the ratio is 4/10 and can be written as a fraction, a decimal, or a percent. Another important term when discussing ratios is rate. A rate is the number of units in the first quantity for every 1 unit of the second quantity. Every ratio has an associated rate. In the ratio A to B, the rate is A over B units of the first quantity, A, for every 1 unit of the second quantity, B. For example, 2 cans of red paint to 3 cans of white paint. The rate is 2/3 can of red paint for every 1 can of white paint. Notice there is just one of the second quantity, which is white paint. Rates can be described in terms of for each one, or for each, or per. Now let's look at ratio notation. Two common notations for writing a ratio are a colon, such as 3:12, and as a fraction bar. When students are first introduced to ratios, it is recommended to write all ratios using a colon, so students don't get confused with fraction operations. Once students have had some experience and understand what a ratio is, fraction bars can be used with labels to distinguish it from the part-to-whole fraction interpretation. For example, a ratio of 3 boys to 12 girls should be written as this. Ratios can either record a part-to-whole comparison or a part-to-part comparison, whereas a fraction only records a part-to-whole comparison. Ratios written with a colon or fraction bar are read the same way. For example, these ratios are both read as 3:12. They can also be read as 3 per 12, 3 for 12, 3 for every 12, 3 out of every 12, 3 parts to 12 parts. For every 3 there are 12, 3 is to 12, and the ratio of 3:12. There are some misconceptions that can occur when writing ratios as a fraction. One example is that when a ratio is doubled, such as 1:4 becoming 2:8, written in fraction form, students may think that 1/4 times 2 is 2/4, because the denominator is not multiplied when working with fractions. This is true when multiplying fractions, but this is not the case when doubling a ratio. Another misconception can occur when adding ratios. For example, 1:4 plus 1:4 can produce the ratio 2:8. When adding fractions, 1/4 plus 1/4 equals 2/4 because the denominators are not added together. In this chapter, students learn about ratios and ratio notation. Students will learn about the different ways to represent, write, and say ratios. Allow students time to think about the different ways ratios can be written. If students are given enough time, talk, and experience with ratios, they will be more successful with the strategies taught in 7th grade.